Welcome to the Meat and Potatoes podcast. Today we're here with Andre Zeitoun and Eric Miller. Andre is the CEO of Ionic Mineral Technologies, and Eric is the CFO. How are you guys?
Doing great, thank you.
Thank you for joining. I'm excited about this one because there's a lot of real-world application. It'll, for the 500th time, drive home the point that I should have paid attention in science class. And it's been in the news, quite prevalent for the last 5-6 years. But there's some naysayers and there's some proponents of it. But you guys are doing some really cool stuff. So start with you, Andre, founding story of Ionic Mineral Technologies and a little bit of your background, if you could just weave those two in together.
Sure. Yeah. Thanks, Garrett. So just some background, introducing Ionic Mineral Technologies. What we do is essentially we're a nano-silicon anode producer. And so we have a very unique way. Essentially, we've kind of cracked the code of being able to make, silicon at the nanoscale, which has been very, very difficult. And essentially the big problem to address here is that, and the reason why nano-silicon is so in demand right now is that nano-silicon is the only, anode material that can essentially drop into existing, battery production, a lithium-ion battery production, and essentially, enable significantly longer range vehicles, but more importantly, addresses the need for fast charging. So, this is something where you essentially can charge your vehicle, over 50 to 70% in less than 10 minutes, equivalent to filling up your, gas tank. And so, so that's, in a nutshell, what Ionic, Mineral Technologies essentially is doing. And but my background and kind of how I've gotten involved in this is, which is kind of unique to this, to our business model, is really based on my been fascinated with this mineral that is abundant here in Utah called halloysite. And halloysite is a silicate clay mineral, but what's unique about it is that it forms a naturally occurring nanotube. And so I've been fascinated with with that mineral because of the many different potential solutions that it brings. But so I've been here over 10 years essentially with kind of pioneering applications and markets for this mineral. And then when the need for nano-silicon, for lithium-ion batteries, came up, that's when I started Ionic Mineral Technologies 3 years ago, focused exclusively on utilizing, our resource of halloysite, which is in Eureka, and using our kind of novel process to convert it to silicon.
Very cool. And for those that don't know, Eureka is about 75 miles away from Salt Lake to the southwest.
Yep, exactly.
And so you actually have the mine.
Yep.
And that's where the beginnings of the magic happen.
That's right. You were the only vertically integrated producer of nano-silicon, and we have our mine is called Halloysite Hills, and we have got just based about a 650 acre property. We've done drilling on only about 20% of it, and with that, we've got basically 2.4 million tons initially, but significant opportunity for much more drilling. But that converts to about 50 million electric vehicles just over the life of that initial reserve.
Yeah, that's a good number.
Yeah,
very cool. I love having the CFOs on the podcast. It doesn't happen that often.
Happy to be here.
But there's a reason why you guys exist, right?
Yeah.
Give us a little bit about your background, what led you to join the company, and I know it's difficult, but a quick snapshot of what a CFO would do at this stage of a company.
Sure. I think I'll be honest with you. I did not know what halloysite was coming in. I had to Google how to pronounce it. But, I am in the space. I was in the space. My career has been in advanced manufacturing, automotive manufacturing, launching products. I worked for much bigger companies. Most recently was a part of the founding team for a synthetic graphite company. So that is the kind of the conventional anode or the conventional material used today. And, so I was plugged in and I knew what nano-silicon was, what it can do, why it's important, kind of addresses that fast charging, gives you the range that, I think people want. So when I saw Ionic and when I saw what Andre was doing about 6 months ago, I had to learn more. I almost didn't believe it, because it addressed some of the things that I think from my standpoint, knowing the industry, knowing the competitive landscape, things that were limitations, like you can only bring so much material to market so quickly and the costs are so much. And I'll, CFO, right? Ionic broke the math. It broke my assumption. So had to come out here, had to check it out. And once I did, that was kind of it.
Very cool. It's nice when you're thinking very highly of something, whether it's a steak dinner or a product or a job, and it actually fulfills on that. It's a good feeling.
Yeah. And, it's fun to answer your other question, it's fun to be a CFO at this stage. I think we've made some amazing progress, and I think Andre's going to talk more about that. And, like any startup, I'm sure you hear a lot of this is, you get to kind of engage across the spectrum. It's not just, spreadsheets all day.
Yeah.
It might be, getting your hands a little bit dirty, learning how to, interpret battery results. It might be more, it might just be kind of cleaning up the mess.
Yeah.
It's everything in between when you're a startup.
Yeah. Andre, for you, I don't generally say this because I'm a glass half full type of guy, but others might say, "Oh, it sounds too good to be true."
Yeah.
Does that happen to you?
Yeah, just like Eric was saying, I got to come here and see this, and everyone who's actually come and seen our operation, seen our, our pilot plant, seen our, results and labs and whatnot, walk away with a different view. Also some of the, customers we're dealing with, seems too good to be true on the surface until you actually, take a look under the hood.
Yeah. And to take a look under the hood, that requires, a pretty solid background in engineering and science and some math, I would assume. Yeah. Ultimately, like, this is too hard. This is a 5-hour podcast, but you pull it out of the earth. Mm-hmm. And you were mentioning to me and showing me a few pictures. You have a new production plant over by the Provo Airport.
That's right.
Can we just start with pulling it from the earth? And if you can summarize like that to when you're talking to the end customers and, having transactions.
Sure. So, as I mentioned before, like our deposit is it is the largest known halloysite deposit in the world. We have a very environmentally friendly, if you can, talk about mining in that way. We're not using explosives. We're not using any chemicals. We're not using even any water. So essentially, it's an open pit, mine, kind of quarry style. From there, we take it and we essentially wet grind it down into its primary particle size. Halloysite's an aluminum silicate, so it's 50% silica, 50% alumina. So the next step in our process essentially is to wash the alumina out with a slight, acid wash. Interestingly, we actually recapture the alumina that's been removed from it as a valuable byproduct, and alumina is on the critical minerals list. So we're actually making a critical mineral as a byproduct. And once what we're left with there now is just a full silicon oxide nanotube. Our patented process essentially. So what we've done is now how do you keep an oxide? How do you keep the particle structure of an oxide? After reducing it down to its elemental metal. And so what we've done is we have two PhDs who've done their as part of our team that have actually done their thesis on this particular process, but with other feedstock sources. But essentially, what we do is we do what's called a metallothermic reduction process. We blend it either with a metal reductant, whether it's magnesium or aluminum. There's other metals as well, but those are the two main ones. And we're able to put it through a low temperature furnace, essentially, And we're able to essentially convert it at a low temperature, less than 700 C, even using this electrical, energy. And by doing that, essentially the Mg, let's say, takes that oxygen from the SiO, and once you heat it to its melting temperature, it scavenges the oxygen, and now it leaves Si plus MgO. All right. And by keeping it at that low temperature, we're able to keep the nanotube structure of the halloysite feedstock intact, and that's really what's key for the material to work in the actual battery. And so, second step after that is now we do a lead acid wash to take the MgO out of the silicon. We recapture that in the form of magnesium chloride, and we'll give that right back to the magnesium producer to now take it and actually convert it back into, metal again. So we're producing no waste in our process. We're actually creating, one critical mineral byproduct and actually recycling any of the chemicals and not disturbing, essentially the water's purified that we're actually using. So it's very, our process is highly, focused on, having a very clean process. There's a lot of materials out there, and there's a lot of the naysayers saying, oh, these materials that are going into batteries are so, it's just kind of a joke. There's so much carbon emitted per ton of the materials being used. There's so much waste that's, in the byproduct streams that it's kind of a joke. In our particular case, we want to we're highly focused on making sure that's actually not the case in our process. So that's something we're very proud of, and as a result, I think of any battery material, we have the lowest carbon emitted per ton of active material that's produced for batteries.
Fascinating and very cool, and also logical, right? Like if you can pull 3 revenue streams out of one, better.
Kind of thing that CFOs love.
Right.
Right. Yeah.
And the folks that love Mother Nature and want a cleaner Earth are happy too, which if you're not one of those people, then it's just kind of weird, right? That is very cool. So then I assume you guys aren't like creating and manufacturing the batteries in-house. There's the end user, whether it's Tesla or Panasonic or pick your logo. That's where the transaction happens, or is there a few more steps in between?
So we sell a powder.
Okay.
An active anode material is what you heard earlier. So we don't make batteries. We do have some capabilities in-house to feed our R&D. So we've got this great feedback loop. So we can make coin cells, half cells, and we can kind of characterize our material. And we put a lot of energy into that. So a lot of fun toys if you're a battery material scientist. But no, we don't make batteries. We would sell, and I think one interesting thing about our product is it's a true drop-in. So we can sell to the existing supply chain. So it doesn't require someone like you mentioned, Tesla or Panasonic. They've invested billions in their infrastructure, how they make batteries today, how they, the form factor, how material comes in, like every little detail is optimized. And the beauty of what we provide is something that really, truly can just drop in. So that's kind of where we fit into the food chain.
Very cool.
Yeah.
And then those that it drops in, they get to change the number on their website of the range of their cars eventually.
Yeah.
Or the hours that their battery
but in the
runs.
right direction.
Yeah.
Yeah.
In the right
Yeah,
direction.
Exactly.
And then somebody's like, okay, finally. And then they go and write a check.
Yeah.
Okay.
Yeah, and I think that ties into another thing here too. Now with the Biden IRA and whatnot, which is really incentivizing manufacturing of both battery cells as well as critical materials, and there's a tax credit for EV buyers of $7,500 if at least a certain percentage of the critical materials are used in the battery are procured here or manufactured here, extracted here, recycled here, but also same with the battery pack. So all the production plants that have been, there's how many billions of dollars has been announced in the last year, they're all being built based on the existing chemistry using graphite. So you hear a lot of news about new battery technologies, and that are promising to change the whole world, the way we live. And, but the reality is that, being able to have a material that can drop into an existing process, right, can improve, the range as well as charging speeds, is critical, because that investment's been made.
Yeah.
And so I think another big, thing for us to be able to have a drop-in solution for any battery maker. You're already buying graphite powder, you can buy silicon powder. If you want to substitute 10, 20, 30%, up to 100%, that's at your, you can do that without changing any tooling or anything in your process.
Very cool. And cars are easy to talk about because people see them every day, and some of them are fun to drive, and we all need them. Most of us need them. But then you've got buses, trucks, utility trucks, and then flying taxis.
Yeah.
Like everything kind of opens up now, right? Where before it was like, we can make one of these and it can fly for 10 minutes for a little promo video, but
Yeah.
I wouldn't get in it for 11
Right.
minutes.
Probably a good idea. Yeah.
So it's all amazing, and it's trillions of hours of humankind's intelligence like culminating here. But theoretically, this would open up doors for some of the more Jetson-like stuff as well. Is that correct?
Absolutely. Anything, from military, applications to, flying taxis, the answer to solving some of these problems is all in the battery.
Yeah.
Right. And the technology that's used today with graphites from 1980,
Yeah.
there hasn't been a need like there is today. And so, I think, you're going to see a lot of innovation, because there's a lot of money being, going into that right now, essentially because of the big need, not just for EVs, but for everything, consumer electronics to flying taxis.
Yeah. And I assume this will kind of change how the engineers, whether it's a little Nintendo or, because I have a walkie-talkie from when I was a teenager that still works, right? So there's Duracell batteries. But I think the engineer that made that little walkie-talkie made it better than the other ones that like only last 1 hour, right? So I assume they'll start to engineer their stuff to what they always hoped was feasible.
Absolutely.
Yeah.
You're seeing a tremendous amount of investment, from companies from at the cell level, across the board in different, additives, for batteries. So yeah, there's just a ton of effort and investment going into continuous optimization and improvement
Yeah.
to be able to kind of reach these next generation, thresholds essentially of performance.
Yeah.
And I think to your point, it opens up new applications, right? So with a faster charging, more energy dense material, lightweighting becomes really practical.
Yeah.
And you can get more out of that battery. So things that weren't possible are, they're possible now.
Yeah. As you mentioned the timeline a little bit, Andre, like you've been at this for a while, and Eric, you mentioned you're a new convert and now you're part of the team. There's a new big, awesome, cool facility going in by the Provo airport. Where are you guys focusing your energy now versus, a year ago or 2 years ago? Because I think it seems like you're in a gear shift right now into a new phase of the business. Where's the focus?
Yeah. So essentially, last September, we emerged from stealth mode. And we did that in conjunction with the announcement of our pilot plant commissioning. So we had a initial smaller pilot plant. We patented our process there, and we also produced material. Had several industry end users validate our material, and essentially 1 year later, year later, we're moving now into kind of, full production. Again, we went from a 7,000 square foot pilot plant and now to a 37,000 square foot facility that will be able to house us, at least our, we're doing our initial 2,000 tons. So by 2024, by the end of by the second quarter, beginning of third quarter, we'll be in production with our first 2,000 tons. which is, you know, essentially the equivalent of, you know, about 20,000 tons of graphite production, which, you know, there's 180 pounds of anode materials per car battery. So you can do the math, how many,
Oh,
you know,
wow.
vehicles that will actually power. And that's just on our initial 2,000 tons. So we'll be the first, you know, mass scale, if you will, looking at, you know, at the 1,000-ton scale of any producer of nanosilicon in the U.S. and one of the only in the world to move this quick. And so then from there we have plans to then scale into our next 5,000, you know, tons. And then we're also working with some, you know, major kind of engineering firms, you know, on a new, you know, 25,000 ton turnkey, you know, large scale manufacturing facility that will, you know, take place probably after 26.
Very cool. I hear that. It just sounds amazing and a lot of hard work and validation. In the mind of a CFO, what does that sound like to you, Eric?
You know, I think the growth story is awesome. I mean, the progress that Andre and the team have made, the progress that we're making, what we have ahead of us, it's really something special. I love the process that Andre described earlier. It enables that faster jump to commercialization, to scale. You know, we are, at the end of the day, we're taking something and subtracting to get to, you know, an end product, battery material. A lot of our competitors are trying to build something up, and that's just more complex. It costs more. It just comes with more, you know, more complications. And, you know, I think as a function of that, you know, we're having to solve, you know, like we're growing quickly. So, you know, that's kind of, you know, the mode that we're in. I think the mode that we'll be in. We've been, I think, really fortunate to have excellent partners and just a great team. And I think, you know, it's like the proximity of the mine. So we're 40 miles away from Eureka to Provo. You know, that is something that is also special too. Just having that, you know, hyper local. It doesn't really exist in the battery material supply chain. That, you know, sometimes things are traveling, you know, across the ocean and then back, and it's more common than I think people realize.
Yeah.
So I think all of those things make for, you know, a unique opportunity.
Absolutely. Yeah, those are infuriating when you see the supply chains going back and forth over the Pacific Ocean.
Yeah.
Once, maybe even twice. And it's like, come on, guys.
Yeah.
This is not a good infomercial for efficiency.
Yeah.
Right?
Yeah. Well, you know what, we can do better, I
Yeah.
think, is the point. And, you know, that, like that, you know, anecdotally you were kind of throwing out, but that happens. It happens a lot. And I think, you know, our material having that 10x energy density and then the proximity for the full life cycle, I mean, that's really kind of, it's local, it's domestic. You know, I think that's kind of what we're all about.
Yeah. And have you guys raised funds, thought about fundraising? Is it bootstrapped? What's the partners as far as finance go?
Yeah, so we've raised some funds up through a Series A, you know, to date, and we are we're very close on finalizing a Series B at this point, which would actually, you know, fund us to free cash flow, you know, positive, and so yeah, we've been, you know, keeping some of those discussions more strategic, you know, led, but at the same time, you know, we've got a kind of gamut of you know, interesting people who are also very interested in the business, who may also be able to be helpful. So
for sure,
yeah,
I assume it gets a little bit easier with each passing day on the investment side, which is a good thing.
I think as you get more meat on the bones, you know, I think you know, it definitely. You know, we always encourage, you know, when they come kick the tires, come see our operations, but see the mines, see our labs, see our you know, our production, and so we love that, and you know, that's you know, yeah, as Eric said earlier, I mean, we're very lucky to have a great team. You know, our technical team's amazing, our operating team, you know, everyone's very, very passionate about it, and I think it just comes through, you know, to anyone who we've, you know, kind of brought to the site to see. You know, and to see, you know, be able to touch and feel something versus, you know, a PowerPoint presentation.
Yep. PowerPoint, bless its heart, it doesn't get you across the finish line a lot of times.
No, it almost never does. Yeah.
So feel free to not answer this question, but if you wanted to predict, like, again, because it's always fun to like project, at least for me, right? I don't have any skin in the game. I just get to talk about it into the future, when this will start to impact a normal person's life. In, let's just say it's cars, like longer, better, faster, quicker.
Yep. So I would say our kind of commercialization timeline. So there's time that you have to get your material qualified through 3-4 rounds. Each sample size, kind of scaling up to the amount that would go into an actual battery. And so right now we have got the ability to produce today enough material to get through that process. So we're kind of looking at 2024 as kind of the qualification process. We have many first testing qualifications. Now we're scaling up to the larger samples to go into full cells, and then ultimately pack level. And so yeah, we're kind of looking at kind of 2024 as a qualification year, but looking at kind of Q1 of 2025 as seeing our material going into real world vehicles, and also electronics and things like that.
Very cool. That'll be fun for you guys, everyone on your team, to start to see that.
That's the dream. Yeah, that's what wakes us up in the morning. Just the whole idea of being able to kind of make that kind of an impact and deliver a solution to really make a major change like that is what's really the most exciting thing.
Yeah, for sure. Well, I look forward to having you guys on again. I'd love to come see what y'all are up to.
Yeah, please do.
And congrats to both of you for what you're doing. We're excited. Thanks for taking the time.
Thank you for having us.